So a horizontal asymptote. Whoa. Oh, wait. A horizontal asymptote, which I'm going to call HA, is defined as the limit as x goes to plus or minus infinity of f of x. Okay, so as x gets really, really, really big or really, really, really small, that is the definition of a horizontal asymptote. My shorthand for horizontal asymptote is HA. Okay, so before we do this, now, we're going to do a bit of hand waving here today, okay? Later on, when we get into the course and we come back to curve sketching, I'll show you, I don't want to say the proper, but the mathematical reason some of this works. But for right now, I just kind of want to look at it from a holistic point of view, I guess, if that makes any sense. So the first thing we have to do is understand a little bit about infinity. So I'm going to, over to the side here, draw a little section. Okay. Oh, one other one that we did yesterday, but we'll do it today. Constant divided by 0. Okay. What is a constant? This is what we did yesterday, the very last one. A constant divided by 0. Infinity, right? Plus or minus infinity. That's what we did yesterday. All right. So that'll be plus or minus infinity. All right. What's a constant divided by infinity?
0.
Okay. Constant divided by infinity. Infinity is a really, really, really big number, right? Like it's not even a number, it's an idea. But it's really, really large. So if you literally just went any constant, pink, 10 divided by, that does not look very good. Exactly. 10 divided by 5, I don't know. Do that. Do that on your calculator. You're going to get 0.00000000. And then you divide by even a bigger number, 0.00000. It's just going to get closer and closer to 0. So we say any constant, doesn't matter how big the constant is, if you divide by infinity, you're going to get 0. Okay? Infinity divided by any constant, so a really, 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 really big number divided by a constant is infinity, a really, really, really big number, right? So this is going to be infinity. Infinity plus infinity will be infinity. Infinity times infinity will be infinity. Makes sense? Infinity minus infinity. Not all infinities are the same. So it's indeterminate. So you can't do it. Indeterminate. You can't do it. And what about infinity divided by infinity? Indeterminate as well. Can't do it. Let's put quotes. We're not going to talk about those. You just have to know you can't do them. All right. So the limit as x goes to infinity of 100 divided by x squared plus 5. So if you plug in infinity, what's infinity squared? What's infinity plus 5? What's a constant divided by infinity?
0.
Now in Math 12, if you remember, we learned those rules where if the degree of the denominator is higher than the degree of the numerator, then the horizontal asymptote is 0. This is why. Okay. So this function has a horizontal asymptote of y is equal to 0. And if you look at the graph, it looks like this. Let's draw it quickly here. As x gets really, really big, it gets closer and closer to the x-axis. And as x gets really, really small, it gets closer and closer to the x-axis. Okay. Are we ready? Next one. X is going to negative infinity of 7 over x cubed minus 20. What is negative infinity cubed? Negative infinity. What's negative infinity minus 20? What is 7 divided by negative infinity? Negative 0. Negative 0. 0. You're just approaching from the negative side now. Okay, so it has a horizontal asymptote of 0. Okay. Limit as x goes to infinity of 3x cubed minus 1000x squared. So right away, you want to plug in infinity, right? I think, maybe. Do we? Yeah. Okay. So if you plug in infinity, you're going to get this. So you get that, which is going to turn into infinity minus infinity. Can you do that?
No.
No, you cannot. That is indeterminate. So we got to rewrite this. So what we do is we go, all right. Can I factor anything out of that? X squared. So I take an x squared out. All right. Okay, now if I plug in infinity, I get this. Do what's in the brackets first. What's 3 times infinity? Infinity, right? What's infinity minus 1000? infinity. So then I'm left with infinity squared times infinity. What does that equal? Infinity. So what's your answer? Infinity. There is no horizontal asymptote. It just spins out of control. Yeah, this one doesn't work. Right? You can't do indeterminate. So that's why you have to rewrite it this way. Indeterminate doesn't tell you anything about the graph. But the limit as x goes to infinity does. It says, I mean, this is a polynomial graph, so you know what it's going to look like. It's going to look something like, it's a cubic graph with a positive leading, so it's going to look something like this, right? So, and you know, so as x goes to infinity, what does the graph do? It goes to infinity. This doesn't tell you anything, right? Like, I don't know what that means. Okay, so this just tells you that you're going to infinity. You're going to see later on when we do curve sketching, this is really important because we're going to look at slant asymptotes, and this is how you figure it out. Why what? Oh, we went 3 times infinity. Infinity minus a constant is infinity. All right, next one. Can you try it on your own? Try the next one on your own. In the what? Second one? This is a horizontal asymptote. This is the definition of a horizontal asymptote. As x goes to positive, negative infinity. Okay? We're not sketching them yet. That's going to come later in the course. We're just calculating them right now. Don't worry about that right now. I won't ask you to sketch the graphs. Okay? Right now. Later on, yes, but not right now. Okay. Did we do the fourth one? Oh, wait. Are we done? Let me see what I get. What's the answer? Infinity? Right? Because if you put in negative infinity and you raise it to the power of 4, you get positive infinity. And then negative infinity to the power of 2 is positive infinity. Infinity to the 4 is infinity. 5 times infinity is infinity. You can add infinities. That just gives you a bigger infinity. I'm saying infinity a lot here. Right? Do you understand why there's different infinities? How many numbers are there between 0 and 1? There's an infinite number of numbers, right? Yes? 0, 1. There's an infinite number of numbers there. Amount of numbers. But if I said, how many are there between 0 and 10? Infinity. Are those infinities the same? Clearly they're not, right? Now that's a very simplistic view of it. And this guy called Joseph Cantor, he's a Russian mathematician. He studied all this stuff and proved the existence of different infinities. He went a little nuts afterwards, probably because he's working with infinities all the time, and it's like crazy. But you can look him up. He became a recluse and stuff and just stopped doing math. But there are different infinities. Okay, I know that's a weird concept, but there are. Okay. All right, flip the page. Now the fun stuff. But it's actually easier. Look at this stuff, peoples. Okay. You have this? All right. The limit as x goes to infinity of cosine 1 over x. Okay, so here we go. If you put infinity into there, you get cos of 1 over infinity. Any constant divided by infinity is? Cosine of 0 is, look at the graphs, 1. Cosine of 0, this is the cosine graph, 0 as a value of 1. Or you can punch in your calculator, either way. So what's the horizontal asymptote of this graph? It's 1, and this is what the graph looks like. I don't expect you to graph it, but... So this is one of the ones, remember at the beginning when I did limits and they oscillate at 0? This is one that looks like that. So it oscillates, it comes in from the negative side. This is at 1, and it goes like this. And then on the other side, it goes... And it has a horizontal asymptote at y is equal to 1. I don't expect you to remember that graph, but if you want, you could. All right. Just for fun. B, e to the power of x squared plus 2x plus 1. E to the infinity squared plus 2 times infinity plus 1. Can you add infinities? Yes, you get infinity. So we get e to the infinity. What's e? E, for those that don't know, is 2.718. Blah, 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 blah. It's a number. It's like pi. Okay? Yeah. So any number to the power of infinity is infinity. No horizontal asymptote. It's good times, isn't it, people? Because it's going to infinity. Horizontal asymptote means it approaches a number. A single number like this approaches 1. As x gets really, really big. This just spins out of control and goes higher and higher and higher. Like this one, I see you looking at your previous page. So this one has no horizontal asymptote either. If it equals infinity, it's no horizontal asymptote. No horizontal asymptote. If it equals a number, that's the horizontal asymptote. Right. Okay. C. We're going to negative infinity, peoples. What is the answer? Who thinks it's infinity? So, negative infinity squared is infinity times negative 5. So negative infinity plus 1. Negative infinity plus 1 is negative infinity. What does a negative exponent mean? E to the infinity we just calculated was infinity. Constant over infinity is 0. And this graph looks like this. Again, I don't expect that you know the graphs. We will get into curve sketching later on. Okay? All right, can you tell me what D is? You're not allowed to answer. So if I put infinity into D, what's 1 over infinity? 0. Would any base to the power of 0 is? You want to know what that graph looks like? Not really, peoples. looks like this. You have a vertical asymptote at x equals 0 and horizontal at 1. And this side of the graph comes in and ends right there. That's your graph. I will never ask you to sketch that graph. All right, last one. Impress me, people. Are you ready? 2? Because these both go to 0. So sine of 0. Sine of 0 is 0. Cosine of 0 is 1. You get 0 plus 1, which is 1. 2 to the 1 is 2. All right. Are we ready for some practice? 2, 2, 15, 17, 19 to 25 odd, please. I still have one more thing to do, but it's a very, very short thing. So I'll give you some time to practice that.